That note come up. Okay, all right, guys. So welcome back. So it's 10th of May, and what we'll do today, I'll do a short. I'll do a short discussion today, probably about an hour. We'll just do 1 hour. Since there is the whole holiday this week, and there was some confusion about, was today and tomorrow going to be a holiday or not. So we'll figure that out. I'll find out what's supposed to happen. But thank you for those of you who are able to join us today. So I won't do a heavy week this week. We're actually, I think, based on, if I can find it. There it is. All right, let's see. We've got 23 groups. And we can do 1, 2, 3, 4, 5, 6, 8 groups per week. So we could do it in those last 3 weeks. And so we're actually really ahead of the game here in terms of where we have to be by this point. So what I'll do is I will talk a little bit about logical design today to introduce that concept, and then we'll figure out what we'll do tomorrow and then next week. But basically, between today, possibly tomorrow, and next week's classes as well, we'll finish off logical and physical design. Throw in, for good measure, we'll throw in a final exam review somewhere in that. And then we'll be on to group presentations starting in 2 weeks, starting on May 24th. So speaking of group presentations, let me pull up my screen on this because I want to talk a little bit about what your expectations are going forward for the group presentation. So this is my view of the whole MS Teams thing. All right, so here I've posted this announcement, and I changed it up a little bit for today to make it a little bit more clear about. So this, every project manager on their assignment was returned with the following 2 sections as part of their comments. Actually, the assignment did not allow me to post this much text into the feedback section. So what I had to do was I had to message each project manager individually, unfortunately. So, c'est la vie. Oh, that's French. Anyway, so anyone who knows French, you know what that means. Okay, so there was the first section where I said, okay, these were the 4 items that were based on that project assignment. The project assignment was 40% of your final grade, so that's where this 40 comes from. Right. So item 1 was that unnormalized data set where I wanted to see 30 columns with data. Okay, and so for each column, for each 6 columns, you got 1 point. Basically, is how I calculated that. Okay, so if you had 30 columns or more, many of you had many more columns. Great. I mean, you were really trying to analyze a robust system. Great. So that was pretty simple and straightforward. For your ER diagram, your item 2, was it readable? Was it understandable? Remember, I'm coming at this from the position of a non-tech person. I'm trying to come at this from both tech and non-tech person. So if I was a real customer that might not understand how databases work, would I be able to understand how you were designing the system to make sure that it met my needs? Right? So you needed to have entities that made sense and relationships, and all the entities needed to have attributes that made sense where they were, and the relationships between some of those entities. Some of you had just these standalone tables. There were some that made sense, but for the most part, if you had a standalone table, it could represent that you were trying to include as part of your system something that should not even be in the system, that it should be connected to something outside of the system that then should connect back to something else inside of the system. Another possibility is you may not have thought through how that table should be related to other tables in your scope. Okay. For that third section, what I was expecting was you needed to have create statements to create the tables. You needed to have insert statements to insert using select to get the data from the UNF from the first normal form table into the second normal form, and then to get the data either from the unnormalized form or from the second normal form table into the third normal form table. Anyway, the whole point is you needed to use existing data. Don't write another insert statement that just throws in more static data into there, because there's no guarantee that what you are getting is the original source data, right? Okay. Then you needed to alter your table. So if you have an unnormalized form database, then you need to drop columns from there, or drop the table entirely. You probably, many of you left that table there, and then if you have a table, it needs to show up in your ER diagram. And that's not to say that you always have to drop that table. In fact, many times that table can represent some central table that kind of stores all the connections between all the other tables, right? It has a purpose, but you either needed to rename it to something that made sense, or you needed to drop it if it didn't need to be there at all. So either way, you needed to take care of that first normal form table in some way. And then finally, the last item was the view. You needed to create a view that had all of your columns from your original table, first normal form, unnormalized, however you want to look at it, and that linked all of your new tables together to kind of recreate a view that looks like your original table. Okay, so some of you, I was very pleased that it looked like all of the groups created a view. That was good. Pretty much in the years past, the big problem has been most groups did not create a view. They just put the select query in there. But some of you created multiple views. Some of you created a view that did not include all the columns. So that was basically, that was what I was looking for there. Okay. All right. All the projects were really well done. You know, I wasn't, there wasn't any project that I was like, oh, this is just a really bad project. They were all well done. They just all, just many of you just have a few modifications that you need to make. One thing I do want to point out, so for the final presentation, these expectations that weren't met will be graded. So I want to know, did you fix the problems that I saw in your original design? Okay, so you need to make sure to fix that. All right. In addition to fixing what wasn't there, you need to add what or fix what may not have been quite as expected. You need to make sure that you add to your system according to the customer requests. So every single one of you got this text with specifically they would like the system to, and then I put in something that was not part of your original design. It could be a column that you didn't have. It could be a table that you didn't have. Whatever is stated here is stated in such a way that based on what I saw in your design, I would expect that you should add some new table or column to your design. All right. And then an additional change here that should force you to modify in some way your original entity relationship diagram. Okay. These are two separate things. Okay. You're probably not, I don't think on any group that the two changes that are requested would be done through the same means. Okay, you're going to need to change your original ER diagram. You're going to in some way need to modify a table or add a table. Okay, and then finally, I gave you 5 queries. 5, we want to make sure we can see or do something using your system. Now, I say the user interface option. Again, this class is concerned with databases. Okay, this is not a user interface class. And so, therefore, I am not expecting you to spend a lot of time. In fact, I hope you don't spend a lot of time creating a workable user interface. Okay? But it is a database, which means that our users are going to need to interact with it in some way. So the point is, what I want to know is, do you understand how to write these queries in such a way that we could put them into a user interface that the user interface would just basically just call the query and the query would do all the work. Okay. All right. So each of these should be able to be done using a single query. It should not. So basically, I need 5 queries of some kind. Okay. So one of them should involve getting data from multiple tables. So you should be able to link them, show that you can link tables together in some way. One of them should show that you know how to use an aggregate function. One of them should show that you can change an existing value in a row, in a column or row. One of them should show that you know how to put new data into a row or rows. I guess I should have put or rows of data. One should also show you that you know how to remove data from the database. Okay, not very difficult, but remember, the main thing that I'm wanting to know from these is the queries themselves, the SQL, okay, or the other language. If you're not doing an SQL-based database, right, then you need to show that you know how to write these queries to make that database select or whatever. Okay, whatever the keywords are. Okay, I'm not going to tell you what those are here. All right. Okay, so again, presentation and report grade will be based on correcting the stuff from the first section. And yeah, okay, so I'm not doing this now. I'm reviewing the expectations now. Okay. All right, so check with, if you haven't already, check with your project manager to make sure that you understand what the expectations are. If there are things that are unclear, if there are things that are like, customer, we can't do that. It's not possible. Or so if you think that it's not possible, contact the customer so that they can kind of talk with you about why they're expecting that what they've asked you to do is possible. But let me advise you, don't just ignore your customer. Okay, don't just say, well, that wasn't part of why we designed this system. Customer wants something we don't want to do, so therefore we're not going to do it. My experience is that customers don't like being ignored. Okay, I don't know about Turkish companies. I've never worked for a Turkish company. Okay, but in my experience with the companies I have worked for, if you say to a customer who makes a request, nah, we're just not going to do that, they tend to not continue to do business with you. Okay, so yeah, so if there is something in what you're thinking is that's just not possible, we cannot do that, then you need to talk with your customer to figure out why they think it's possible. Okay, all right. So enough about group project. Let's talk a bit about logical database design.
Sir, can I ask a question?
Sure.
It was about the group projects. I understand everything you told, but do you know there were any group who get full score out of it?
Let's see. I don't think so. I think the highest one. Let's see. Nope. There were a couple of 38s and quite a few 36s.
Okay. Thank you.
Sure. All right.
So when we can ask about our project mistakes.
Just go ahead and contact me. A few groups have already contacted me.
Well, I am not the project leader, so can I ask?
Sure.
Okay, thank you.
Yeah. Okay. But make sure you talk to your project manager about and that you have read the feedback first, okay?
Okay, okay.
All right. Let's see. So, okay, logical design. Here we go. All right, so remember the output of the conceptual data model, the conceptual design phase, the output was the entity relationship diagram, the initial entity relationship diagram. Now, during the logical phase, we should not need to modify it too much. There might be some changes. And again, one of the things that is going to be the output of the logical model will not be another ER model. It'll actually be a data dictionary, a data model. And so what we're going to be doing here is we're going to be taking the entity relationship model, the ER diagram, and we're going to try to figure out what of that needs to become tables. How do those relationships get resolved? Because in a database, as you guys have figured out through creating a MySQL database, or for some of you other types of databases, you have discovered that you don't get to just draw a diagram and that makes the database for you, right? That you have to create tables. You have to create foreign key constraints. Those represent relationships between tables. You have to put integrity constraints on the tables, on some of the columns, and in other types of constraints as well. And so this phase, what this is all about, is taking that ER model and trying to discover, okay, what type of relations, what type of tables will come out of that. Okay. So the way we're going to do this, we're going to derive relations. So the first step is going to be say, okay, how do we take the entities in our ER model and discover which ones should be tables, which ones should be more than one table. Sometimes some entities, two of them together make one table, and we're going to discover how that happens in the first step. So if we look at the initial ER model, so the way what we come into, this was what we left off with at the end of the conceptual phase. Our customer, we've reviewed this with our customer. Our customer has said, yep, that looks good to me, right? That property, client, own, yeah, okay, good. I like it. It's good. I'm good with this. And so now we're going to take this and say, okay, what of this are we going to say should become our different tables, and how should we resolve these relationships as well? Okay. So there's a couple of things that we'll need to identify are things like what is a strong entity type versus a weak entity type. What about one-to-many binary relationship types? There's also the other types of relationships we've talked about, the one-to-one, the many-to-many. Right? And so we'll talk about how to resolve those relationships. What columns do we need to add, or possibly tables do we need to add in order to make those relationships happen? Okay. All right. Okay. So again, our model. So we'll also talk about one-to-one binary relationship types. Now, oh wait, I think, did it say? Yeah, okay, sorry. One thing I wanted to say here, I skipped over a part here. In the one-to-many binary relationship is the easiest one to resolve. Okay, we basically put a foreign key column onto the side that represents the child, that represents the many side. Okay, so the one side, the thing with the side that have the relationship that has the one on it, right, we call that the parent or the strong, right? And the many side, we'll call that the child. And what we do is we put a foreign key column into the child that points to the parent. So if we look at our original model here, let's find a one-to-many relationship. Not staff and supervisors. Fine. Okay, like, oh, here we go. Here, easy. Owner owns property for rent. So an owner is the one side, it's the parent. The property for rent is the many side, so it's the child. And what we say is that what we'll do to resolve this relationship very simply, in the entity that represents, the relation that represents the property for rent, we will add a column here that is a foreign key to the primary key of the owner table. Okay. And so here, if we want to say, okay, for the property for rent, who is the one person, the one value that owns that property, we look in its foreign key column. Okay. If we were to say, okay, well, what are the properties that a certain owner owns? We take the owner number primary key. We take the owner number primary key, and we look in property for rent for any rows that have that owner number value. Okay. And in this way, we don't duplicate any data. We wouldn't want to put a column over here in the owner table to show the property for rent. And the reason why is because the owner can own multiple properties for rent. So if we put a column over here in the owner table, what would happen? If we put a column over here, in order to show which properties the owner owns, we would have to have a new row. We'd have to have a new row in the owner table for every property that owner owns. Well, if we do that, then we're duplicating this other data, the owner number, the address, the telephone number, but we can't do that. Well, for one thing, the owner number is a primary key, so we can't have a duplicate in that value at all. All right. But if we put a foreign key column here in the property for rent table, and in that value, in that foreign key column, we put the owner number that owns that property for rent, then we maintain that referential integrity. Okay. Let me see. Still not charged. Okay. All right. So one to many, easy. There's an old saying, easy peasy, lemon squeezy. I don't know who came up with that or what it means, but the one to many relationship is the easiest type to determine what to do. Okay. You go to this guy over here, the many side, you put a foreign key column here that points to the primary key column of the one-sided table. Okay. All right. So let's get into some harder relationship types. One-to-one. Okay. We have a one-to-one binary relationship. There's three possible ways that we can look at this. There's either mandatory participation on both sides. If one exists on one side, it has to exist on the other. And vice versa. Okay. There's mandatory participation on one side, which means one side has to have a value. The other side, not necessarily. Okay. Let's imagine that for this first one, one-to-one with mandatory participation. Okay, let's say we're having a marriage conference. Okay, a marriage retreat for people who are married, for couples to come to and get counseling and get help so that their marriages can be better. Okay, mandatory participation on both sides. We have a men's table, we have a man table, a woman table. There must be one man for every woman because it's a marriage conference, right? It wouldn't make sense for me to go to a marriage conference without my wife, all right? And so for every man in our conference, there must be a woman. For every woman at our conference, there must be one and only one man, okay? Second option, mandatory participation on one side of the relationship. Let's go men and women married again, but this time it's a men's conference. It's a men's group. They're getting together to try to discuss how to be better husbands. Right? Very important. Very important. Okay. But I don't know. Maybe it's a men's conference, just how to be better men. I don't know. But some of them are married, some of them are not. So on the woman's side of that, right, on the women's side, they may or may not have an entry. Optional participation on both sides. We have a man table and a woman table that represents everybody in the world, every person in the world. Some of them are married, some of them are not. Some women are single, some women are married, some men are single, some men are married. Okay. All right. I hope that's kind of clear. It was clearer in my head than when I spoke it. Okay. But those are the three different possibilities: is mandatory on both sides, optional on both sides, mandatory on one side, optional on the other. Okay. Well, mandatory on both sides is easy. Why have a separate table? If for every row in table A, there must be a matching row in table B, just combine them into one table. Right? Now you have one table that has all the rows from both A and B, that has all the columns from both A and B in it. Okay. Pretty easy. Okay. Mandatory participation on one side. We're going to identify one of the okay, the entity with the optional participation, we're going to designate that as the parent. And the entity with mandatory participation is designated as the child. And we're going to take the child entity, we're going to add a column as a foreign key to the primary key column of the parent. So in my example, which may have been a bad example, right, we have a group of men who are, maybe they're not at a conference. You know what? You know, it's a bunch of old men. Okay? It's a bunch of older men. They're at the tea house, right? They're at the you know, what do you call it? A chayevi? You know, where the older men sit there and they play tabla and they play okay and they sit around, right, drinking tea and talking, right? And some of them are married and some of them are not, right? And you take that, right, and what you do is the child, you take that, and that's the child entity would be the woman table there. And the reason why is that, and I wish my tablet has not charged up yet, and I really wanted to show you guys this through drawing it, because it's much easier to see, I think. In fact, let's do that. Let's what I'll do is I will finish this out today. I'll finish out our discussion today here at 2:20. And then what we will do is tomorrow I'll come back with a charged tablet so that I can draw these things, a whiteboard, so that I can draw these things out so that you can see them better. Okay. So you put a foreign key column in the child entity, in the child relation, that points to the primary key of the parent relation. Okay. In the example I gave, the man table would be considered the parent, meaning it's the one that we keep track of all the rows, right? Because every person, every man at the tea house is going to be in our table, all right? For the other table, the women table, they will have a foreign key column there that points to which man they're married to. Okay. Optional participation on both sides. In this situation, it depends. It depends on what our data looks like, and it also depends on what our data will look like in the future as well. It's pretty much arbitrary in the sense of that in most situations, if it's an optional one-to-one, so in the case of man table of all men in Turkey, women table of all women in Turkey, who's married to who? Well, do we put a foreign key on the women table to the primary key of the men? Do we put a foreign key in the men's table over to the women's table? It depends. It depends on what the data looks like. Okay, and I can show that in more detail when I draw it out tomorrow. Okay. All right. So that's how we deal with those three possible one-to-one relationships. Okay. As for the one-to-one recursive relationship, it is basically the same thing. Right. Again, mandatory participation on both sides. We just do the two copies of the primary key. One to represent the primary key for that row, to represent the identifier for that row. The other to be acting as the foreign key to the other row in that same table that it's matched with. All right. All right. Again, mandatory participation on only one side. We could do the same thing where we have another column for a foreign key that points to the primary key of our existing table, or we could create a new relation, right, that could represent the pairing of the two. Okay, the new relation would have two attributes, one being the primary key to the row where like the supervisor, supervisee type thing, one being the matching row for that to the supervisor, one being for the supervisee, the one being supervised. Okay. Optional participation would work the same way, where we create a new relation. Okay. Now, a difficult one to deal with. All right, so we haven't even gotten to the many-to-many relationship, but another difficult one to deal with is the whole idea of the superclass subclass. Remember, this is a relationship. So here in our example here, a private owner is a type of owner. A business owner is a type of owner. Same thing with the supervisor here. Now remember, there were 4 different combinations, participation and disjoint combinations, mandatory and optional and mandatory or optional or. I hope you guys remember what the difference between those 4 means. Okay, so remember, mandatory and means if I have one of these, it must be one of the ones below. Okay, it must be. So for example, here, if we look back at our table here, our diagram, this is a mandatory. I cannot have somebody that's just an owner, just a regular old owner. It must be either a private owner or a business owner. Okay. We'll talk about the or in just a minute too, but the mandatory part means it must be a child. It must be one of the child entities. Okay. And means it can be more than one. It could be, remember we talked about the person, the staff who was a manager, a secretary, I think, or administrative assistant. I can't remember what all the staff people were, but remember that was the and. It could be any of them. Okay. And the way that we do the mandatory participation, the mandatory and, is we just have a single relation, one single relation to represent all of them. Okay. And we would need to have some type of flag, some type of columns to tell what that row is. Is that a certain type of owner? Is that a certain type of staff person? Okay. All right. Optional and, meaning it can be the main thing. It can be just the whatever the thing is, so the optional and staff person. And it could be more than one of the children. We're going to create two relations out of that. One relation that represents the superclass, because it must be one of those. If we have a row, if we have a staff person, they must at least show up in staff. Right? But it can be any of the bottom, so we're basically going to have another relation for all of the subclasses put together. So basically the reason why we have two relations here and a single relation here is because the mandatory says it must be one of those children. So therefore, and it can be more than one. So instead of creating a bunch of tables and stuff to figure out what these different things are, what we're going to do is we're going to have every row is just whoever that person is, whatever they are, or whatever that entry is, and all of the things, all of the children that it could be as well. Here, the optional and is saying the one relation for the superclass, we know that every row is going to be in that parent relation. Is going to be representative of something of the type of the parent relation. So we're going to have a record there, a row there, and then anything else it might be, any of those children that it might be, we're going to say, okay, that's going to use, we're going to use another relation to represent all of those. Okay. And again, we will have some type of discriminator, some type of row, some type of flag to tell what type each is. Is it a manager and a secretary? Right? Is it a manager and a supervisor? Is it none of those? Right? Well, I guess if it's none, then it just shows up in the parent relation, and we don't have a row in the child. Okay. Finally, the last two, the disjoint, the or. We have a mandatory. It must be one of the children. So that is like this here. The owner with the private owner, business owner. Mandatory or. We're going to create many relations. Okay. One relation for each combined superclass subclass combination. Okay. So we're going to have a relation for the business owner. We're going to have a relation for the private owner. And then an optional, many relations, one relation for the superclass, for if there was an owner, the owner could be just an owner. One relation for the superclass and one for each subclass. And the reason why for this is because it can be one or the other, but not both. If we were to have one relation for all the subclasses like we did here in the AND format, then we would have a lot of columns that would have nulls. Everything that person is not, all the columns representing what type of thing that row is not, would all be nulls, would be blank. And that would be pointless for us to have that. Mm-hmm. So if we look at the example here, the owners, right? So if we were to say we're going to have an owner, private owner, business owner, all right? In our example, we made it mandatory or. But imagine that we had made some design decisions. We made some different design decisions here. If we had a mandatory and, we would just have one big table with owner number being the primary key. Okay. If we had option 2, right, is optional and, we would have an owner table right? Because they could be just an owner, they don't have to be a business owner or a private owner. But since they can be one of those, we'll have the owner details table is going to tell me all of the information of what that private owner or business owner might be. Okay. If we had the mandatory, it must be one of the children. Right? It must be one of the children, or it can only be one of the children. This is the one that actually shows up in our diagram. We have a private owner table and a business owner table. Okay. And then an optional disjoint. It can be just an owner, but if it is one of the child, either private or business, it can only be one but not the other. We have an owner, main owner table, and then for those who are private or business owners, they would be down here. Okay. Now the reason why this is important, and what we'll see is when I am able to draw this out, is one of the things that we are trying to do is we are trying to limit wasted space, and we're trying to limit and get rid of, if possible, duplicate data. And these formats of how these are done is going to do that for us. Okay. So for the example that we actually have, this option 3 is what we would do. Okay. Now, yeah. Now, some of you might be thinking, wait a second. In our first cut ER diagram, we had two separate tables. We had a private owner and a business owner entity. We had two separate entities. And you made us change it to an owner that had a child, private owner and child, business owner. Why did we change it if it was just going to change back to two separate entities, two separate tables? And part of that's because of what made sense to our customer. Remember, the old way where we had two relationships, property for rent to private owner, property for rent to business owner, it was a bit confusing and it might not make complete sense to our customer. This will make a little bit more sense to our customer in that we're saying, here's a restriction, this one-to-one, right? This one-to-many relationship. A property can only have one owner, period. It's going to be either a private or a business owner, but it can only be one. The other part of this is if for some reason somewhere along the way we want to change this mandatory or to optional or mandatory and or something like that, if we want to change that, then we can just by changing the label. Whereas if we wanted to change something about that in the old way, right, it would require a lot more diagram changes than just changing the label. Okay. All right. So one more that I'll talk about here before we dismiss for the day. What about the many-to-many relationship types? Okay. So the problem here is that let's say there's many-to-many. So let's go back to our men and women. And instead of being married, we're just going to say friends with. Okay. We're going to say that men are friends with women, more than one. Women are friends with men, more than one. I'm assuming we all agree with that. Okay. So, well, how do you represent that? Do you put a foreign key column in the man table that points to what women he's friends? Well, then we're duplicating the rows in the men table for every time that a man becomes friends with a woman. And then the same thing is true if we do that in the women table. We put a foreign key column over there, then we got to duplicate rows of the women. But the whole point is we're trying to not duplicate data, right? The whole point is we're trying to not duplicate rows. So how do we do this? Well, the solution that we need to come up with, that we need to do, is we need to create a intermediate table, a table in the middle where every row in that table represents a link between a row in table A and a row in table B. So if a man becomes friends with a woman, we just add a new row to this intermediate table, this table between the two, that says he has become friends with her. They are linked now. And anytime that somebody stops being friends with someone, we just remove the row from that table. Okay. So now we have, let me look here, a many-to-many relationship. Okay, so like here, a client views property for rent. And notice that one of the things I said a long time ago is that generally speaking, you'll see these attributes on a relationship. They'll almost always be many-to-many type attributes. Oh, sorry, many-to-many type relationships. And the reason why is because these attributes can now be added to that new intermediate table. So when a client views a property, that intermediate table, we put the client number in the table, we put the property number in the table, in that row. That row that has that client number and that property number represents the client viewing that property, and we can keep track of what date it happened and what comment they made. Okay. Another example of a many-to-many relationship you guys encounter all the time. A student takes a course, or a student enrolls in a course. Right? A student enrolls in many courses. A course has many students. We put a table in the middle that represents what semester they took it, that represents what their grade was in that semester. Right. So a student taking a course is a many-to-many style relationship, and we can put attributes in that intermediate table. Okay. So I'll end there for today, but what I want to leave you as a take-home, as a thinking assignment, something to think about. Here I said this is a many-to-many relationship, and there's a table in the middle. Okay. Consider, therefore, we assume this table is going to have a relationship with this table. This table is also going to have a relationship with this table. What type of relationship? Don't answer now. Don't write it now. Just think about it. I'll start tomorrow's lecture off with this question. What type of relationship should be between table A and our intermediate table? And what type of relationship should be between table B and our intermediate table? Okay. All right. So we'll end there for today. All right. I hope you guys all are staying safe, and I hope that I hope that we get through this and that these lockdowns can come to a swift and peaceful end. Yes, question, Enes.
So can I ask now about our diagram, if you have a free time?
Yeah, let me go ahead and turn off the recording.